Hello, I'm Alex, I'm a web developer, and today I'm going to tell you all about my first ever attempt at reverse engineering a data file. If you've ever played a real-time strategy game, you'll be familiar with the concept of fog of war. You can't see the map until your units explore it. There's an app called Fog of World that brings this concept into real life. When you install it, the world is covered in fog, and as you move around, the fog is cleared away. I installed it on a whim years ago, but it's really changed my relationship with geography. For instance, it inspires me to take new routes around town, and it's particularly cool when traveling. Here's a trip I took to Quebec City a few years ago. This is my own custom map of the city, and it's detailed enough to show individual streets and parks that we visited. But the app can only export screenshots like these. I wanted access to the data so I could draw my own maps. Although there's no official data export, Fog of World syncs with iCloud and Dropbox. If you look in the sync directory, you'll see a whole bunch of files of varying sizes. And they don't have file extensions, so I had to figure out their contents another way. There's a utility called File that can detect file types, and that identified them as compressed files. After I decompressed them, I ran File again, and File did not recognize them. Now, another useful utility for identifying files is Strings, which looks for human-readable text in data, but that didn't find anything either, so my last resort was to look at the raw data. Let's open the file in hexdump. Hexdump shows three things. It shows an offset into the file, it shows the data itself in bytes, and a human-readable printout if you interpreted those bytes as ASCII text. Now, this is the start of the file. What do you notice? I noticed it's mostly empty, and the stars on the left mean everything between the above and below offsets is the same, so it's even emptier than it looks. If I highlight the non-zero bytes, the data seems to form a line. Now, this is the top of the file. Let's look at the bottom. The end of the files look different. They're much less sparse, and the data starts to reach the printable ASCII range, and it also falls along straight lines. Now, I didn't notice these lines in hexdump because they only stand out when you show 0 bytes differently. But I did know the files were mostly empty, and I wanted to look for patterns, so I wrote some code to print out ASCII diagrams. And I made the character wrapping point configurable. Wrapping at 32 characters, we don't get much. 64 character wrap looks a bit more promising. Wrapping at 128 looks great, and 256 characters looks a bit weird again. So that wrap point at 128 seems like a good bet. And seeing tracks so early was a really encouraging start. But this is just the top of the file. What does the rest of the file look like wrapped at 128 characters? Not great. Not great at all. And this stumped me for a while, because there was clearly a pattern. There's this diagonal line which runs through the data, and the data itself is too regular to be random. Beyond 128 characters per line, it's easier to see this data as an image. Let's discard the initial track at the top of the file and see the rest wrapped at 128 characters. I've rotated it 90 degrees to fit more on the slide. And the diagonal lines are even more apparent, and they suggest we're wrapping at the wrong point. I discovered my diagonals change direction between 257 and 258 characters, and I thought for a while the data was tick-tocking back and forth between 257 and 258, as that did align better, but a clever friend suggested that maybe it was really wrapping at 515 characters, 257 plus 258. And that looks a lot better. This solid black line at the bottom is our former diagonal, and finding this alignment was also really encouraging, but I still didn't know what the data was. I thought, must be location metadata of some kind, but the theory didn't feel quite right. So I had theories but no insights, and I pondered the facts for a day or so. Let's review the clues. First up, something was weird about all the tracks I'd found. Here's them all in one image. Now, these are definitely tracks, but they're not very detailed. The app lets us see individual streets, and that's not visible here. Next, let's have another look at the start of the file in hexdump. This is the track data, but why store it as numbers? The app doesn't need to know about track ordering. And lastly, the ratio of tracks to metadata seemed off. Here's the non-zero bytes of our file again, but with the track included this time. Now, Fog of World is about tracks, and pretty much only tracks. And yet, this was my theory about the file layout. But what if my theory is exactly backwards? What if what I thought were tracks are metadata, and what I thought was metadata was really tracks? Now, this idea came to me one day at work, and I was really excited to go home and try it out. I already had some throwaway code that just kind of poked at the data files. It would read the data and try things like divide the file size by common divisors and count the most frequently occurring values. And my new guess was each number in the top track referred to a 515 byte chunk below. And this held true for all the files. I called this initial track an overmap. Each chunk was 515 bytes, or 512 bytes with 3 left over. 512 bytes is enough for a 64 by 64 pixel square, where each pixel is either on or off. And on or off is all Fog of World cares about. Now, I already had code to draw the overmaps, so it wasn't much work to try this out, and it was extremely satisfying when it worked. The file we've looked at so far is really boring visually, so let's look at a more intricate one. First, let's see one of the 64 by 64 pixel subtiles. I've shown several pixely images at various scales so far, so it's not obvious how small this image is. It's only 2 Super Marios tall, or 4/5 of a Street Fighter. And the subtiles only work when assembled into a bigger map. Here's the overmap for the whole tile, and there's not much detail visible. If we draw each subtile into its overmap location, there's a lot more detail, and this is a low-res preview. Zooming in further, I can show you the subtiles, and this is as granular as it gets. There's a subtile we saw before in context. Now, you might remember that our data chunks are 515 bytes each, but each subtile is made from 512 bytes of pixels. What's the story with the last 3 bytes? Well, I don't know entirely, but I figured out one of them. Let's look at a small part of a different tile, but with the mystery 3 bytes printed as numbers. Almost all the subtiles have the same first mystery byte, not just in this crop, but the entire file, except for one subtile on the right. Now, this track's from Niagara Falls, and I've only ever visited the Canadian side of the falls, but that rightmost subtile, that I've barely visited, is mostly America, so it seemed like it was related to countries. I pulled the country bytes from all the files into a list and sorted them, and then identified some of those countries, because I know where I've been. And it seems a safe bet these are positions in an alphabetized list of ISO 3166 country codes. Now, the other 2 bytes are different, and they don't seem tied to the underlying geography. I have some older backups from Fog of World, so I can compare an older tile with a newer version. And the last 2 bytes change when the pixel data changes, but I don't know more than that yet. Regardless, the bytes don't seem related to drawing maps. Let's return to the file naming. I can render each tile, and I can piece the tiles together by eye. I figured the tile names must be related to its real-world location. And I wrote some code to help me assemble these tiles into a bigger quilt. Here's a chunk of Canada as code, and here's the output. Now, there are definite patterns here. The first 4 characters seem to be a hexadecimal ID, and then the next 4 characters are mostly stable by row, which would suggest the last characters are to do with vertical position, but they have more differences. And some places have longer tile names too. So there's really 2 problems here. Is there a tile for this real-world location, and does this tile have any neighbors? And I haven't solved either, but I am looking for patterns. Here's an example. Let's see all the file names again, but with some duplicate files removed. Different character positions in the file names have different possibilities. The first 4 are clearly hexadecimal, and the next character has only 4 possibilities, which should make you think of a layout scheme like this, or like this, or like this. Unfortunately, my tiles are laid out like this. But in practice, this hasn't been a problem. Sorting tiles by country, combined with the mostly stable row identifier, makes it straightforward to assemble these quilts by hand. And I can now make big maps. Toronto to Ottawa is about 220 miles, or 350 kilometers, so each of these tiles is about 30 miles square, or 50 kilometers square. Now, I've made enough progress to give a talk about this, and I can draw my own maps now, but there are still some open questions. I don't know the meaning of the file naming, or how each file is pinned to the real world, and I also have those 2 bytes for each subtile that are still a mystery. Now, maybe you figured it out already, but if you have, please don't tell me. The Fog of World author seems nice and has some unrelated code on GitHub, so I could probably have just emailed them and asked. But I like puzzles and I want to solve it on my own. Now, this was my first reverse engineering project, so my tips are rudimentary, but it was really fun. So if you like puzzles and you have some mystery data, I definitely recommend trying to figure it out for yourself. One thing that struck me is the power of visualizing data. People often think visualization means charts, but ASCII pictures were enough to confirm I was on the right track. Drawing red squares and numbers on my maps also helped, a graphical equivalent of console.log debugging. And similarly, summarizing data also helped me find patterns and differences. Keeping scratch notes with a stream of consciousness speculation was really useful, especially when I returned to the project after a break. And lastly, even if you're a programmer, don't forget you have other tools too. I used a spreadsheet for some parts of this, and that was a lot quicker. And that's everything. If you have questions or want more details, I'm hanging out in the Bang Bang Con Discord server. Enjoy the rest of your Bang Bang Con.